Scientist and inventor of the telephone, Alexander Graham Bell, once said that with every door that closes, another one opens. Disney princess and sister of Elsa from Frozen, Anna, once said that love is an open door. What do either of these quotes have to do with absolute value? I don't know. But we are closing the door on Unit 3 by opening the door on our final class of Unit 3, Class 6, Problem Solving with Absolute Value Part 2. So, last time we were together, we worked with both absolute value equations and also some inequalities containing absolute value. But how will we know when to use which? In other words, right, we came up with a list of some cue words that could indicate for us which of the two we wanted to use. Look back at your notes. What were some of the words that populated each of those lists? And once you've got it, just to make sure it's fresh in our memory, let's also rewrite the general form of our absolute value equations and inequalities. Go! Alrighty, well, if I'm looking for indicators of an absolute value equation, for absolute value equations, I split into just my positive and negative case. Usually those cases represent the maximum and minimum values of something. Other ways to say maximum and minimum, well, I could also say, right, that I want the biggest and the smallest, or in this case, I'll write the smallest and the biggest because my brain decided let's write smallest first. We could also have the most and the least and any version, right, or variation thereof. For inequalities, though, we're interested in the stuff also in between the max and the minimum, or on the outside of those numbers, words that often indicate the absolute value inequality flavor. Well, I might use a word like the range of values I could be, or the collection of values I could have, the set of things that I'm working with, or the extent of those values. With this in mind, the general form that we were able to reverse engineer, well, I know if I take the absolute value of either the maximum or minimum, if I'm working with equations, right, or the range, if I'm working with inequalities, and from this I subtract my given number or my goal number, maybe it's an average, maybe it's just something I'm shooting for, I don't know, right? Then I take either my equal sign or my greater than or equal to, my less than or my less than or equal to, whichever one suits the context of my problem. And on the other side, I write my absolute deviation. Now, last video was all about showing where this general formula comes from. Now that we've got it, the purpose of this video is to make sure that we feel comfortable using it. So, each of these problems, there are 4 of them in total. I'm not going to explicitly say to you to pause the video, but you might want to pause the video and give it a shot before we move through the problem together. As you move through each one, right, start thinking about where is the given number, where's the absolute deviation, what do I want my variable to represent, right, and is it going to be an equation or an inequality? Cool. First one. The human body's resting internal temperature is typically around 98.6 degrees Fahrenheit, but depending on the person, it may vary by no more than 1.7 degrees in either direction without resulting in hypothermia if it's too cold or fever if it's too hot. What is the range of the body's possible healthy internal temperatures? Again, if you want to pause and give this a shot for yourself, now's your time. If you've already got it solved, or if you are just feeling particularly not pausey today, let's do it together. Reading through this, I want to figure out probably first of all, what am I interested in representing? Well, I want the range of possible healthy internal temperatures. So my variable, maybe I'll call it T for temperature, is going to be the range of internal temperatures. And I know here that my unit, I often like to write off to the side, is going to be in degrees Fahrenheit. That word range here immediately should tell me that I'm working with an absolute value inequality. Looking through the rest of my problem, Well, I'm told that my typical resting range is around 98.6 degrees Fahrenheit. Around, we saw, is one of our indicators for our given number. So my given number here is going to be 98.6 degrees. And I can vary from that given by 1.7 degrees. So this here is going to be our absolute deviation. That absolute deviation here, of course, is going to be 1.7. So all I need to do is slot into my absolute value inequality. So here, I know that the range or the max or min, so in this case, I'm using t for my range, minus my given number of 98.6. In this case, some absolute value symbol, or some inequality symbol, is going to connect it to the absolute deviation on the other side of 1.7. Here, looking at my problem, can you see what's going to tell me what particular absolute or inequality symbol I need? Well, it's actually a series of words. No more than is going to tell me my inequality symbol. Well, if I'm no more than, that means I'm not more than. I could be either less than or equal to. Nice, I've got my inequality set up. All I need to do now is look at my symbol. Is this going to give me a sandwich or a split? Well, logically again, if I am less than or equal to 1.7, that means my distance from 0, I need to be closer to the 0 than the 1.7. So I need to be sandwiched in between my positive and negative cases. So here, what that tells me is that the stuff inside my absolute value, the t minus 98.6, needs to be sandwiched between the positive cases of positive 1.7 and negative 1.7. To solve for t, all I've got to do now is add 98.6 to all three parts of my inequality. On the left, negative 1.7 plus 98.6, well, that would be the same as 98.6 minus 1.7. That would give me 96.9, which is going to be less than or equal to the value of t, which is less than or equal to 98.6 plus 1.7, which I believe is 100.3. All I need now, right, if I'm writing out my actual solution, I would want to write a full sentence. But for the sake of the problems here, right, as long as I've got my unit, that'll give me full credit. So here, 96.9 degrees Fahrenheit is my minimum. 100.3 degrees Fahrenheit is my maximum, and anything in between there is a healthy internal temperature for my body. Cool. Next up, leading up to the 2025 mayoral election in New York City, an October 2025 survey of 600 likely voters conducted by the Manhattan Institute found that 46% of those polled intended to cast their ballot for the race's eventual winner, Zohran Mamdani, with a margin of error of about 3.8%. What are the largest and smallest possible percentage of voters who intended to vote for Mamdani? Alrighty, if you want to pause, now's your shot. If you don't want to pause, let's go. So, looking at the last sentence here, I'm told that I want to represent the largest and smallest possible percentage of voters. So maybe I'll choose V as my variable here. So I'll say let V equal my largest or smallest. I'm going to use max and min because I'm lazy, percentage of voters. If I'm working with a maximum and a minimum, this indeed should tell me I need an equation. So I might even write my equal sign automatically. Slotting into my general formula here. Well, I know that my max and min is going to be represented by the variable V. My given number, looking through my problem, well, 46% of those polled. That seems like a good average. So here, my given number is going to be my 46. And I can vary from that. Remember we said margin of error is another one of our indicators for our absolute deviation when we're working with percentages. Here my margin of error is going to be 3.8. So, slotting in, I know that max or min minus our given number here of 46 is going to be equal to our absolute deviation of 3.8. Nice. To solve this absolute value equation, right, all I need to do is split into my positive and negative cases. For the positive version, if the absolute value is 3.8, then the stuff inside the absolute value, the v minus 46, it could be the positive version of 3.8 or the negative version of 3.8. All I've got to do to solve for v is add that 46 to both sides in each of my equations. For the equation on the left, if I do that, v would be equal to 49.8, and then I'll include my unit here of percent. Or if I add 46 to both sides on the right, then that would give me that v is equal to 46 minus 3.8, which would be 42.2%. So again, in the context of the problem that I would want to write, I would probably want to include a full sentence here, but in this case, my maximum value would be 49.8% of voters. My minimum value would be 42.2%. Coolio. Number 3. International super spy James Bond is piloting a plane through the skies of London. To stay on the trail of a supervillain, he needs to fly through the middle of the Tower Bridge, which is 213 feet tall. To be safe so that he doesn't crash into the bridge, he wants to make sure he has more than 40 feet of distance, either above or below him. What is the range of possible heights that James Bond could fly at to avoid crashing into the bridge? Again, if you want to pause, here's your chance. And if not, let's go. So, in terms of the thing that I'm representing, I want to represent the range of possible heights that he could fly at. So in this case, my variable, maybe I'll choose h for height. Let's use h to represent the range of possible heights. My unit here that I often like to include, well, I'm told is 213 feet, so feet is probably going to be my unit. Range, that word of course tells me that I'm working with an inequality. I'll give myself a second, read through the rest of my problem to figure out which inequality I need. Looking through, 213 feet, well, that is going to be my given, right? That's the height that I'm going to deviate from. So my given number here is going to be 213. And then I want 40 feet of distance away from that 213. So here is my deviation. So my absolute deviation is going to be 40. All I need to do now is slot into my absolute value inequality. So I know that the range in this case of h minus the given number of 213 on the other side of my absolute value inequality is going to be my absolute deviation of 40. Where is my Q word for which inequality symbol I need? Well, looking through the problem, I'm told that I want more than 40 feet of distance. If I want more than, that of course should translate to greater than. Nice. All I've got to do now, let's make sure that I can properly interpret this symbol. If the absolute value is greater than a number, is it going to be a sandwich or a split? Well, the distance needs to be more than 40. I need to be farther from 0 than the positive and negative cases. I need to be on the outsides of those cases. Here's my split. So what that tells me here, I need to be either to the right of the positive 40, so I could be a number bigger than 40, or equivalently, I could be to the left of the negative case, or less than negative 40. Again, to solve here, all I need to do is add 213 to both sides of my inequality. On the left, if I add 213, I would get that h is equal to, or not equal to, sorry, here, greater than 253, and I'll include my unit of feet, or I could have, if I add 213 to the other side, wait, why am I using red? Silly, Mr. Villel, let's be consistent. If I add 213 to both sides in pink, here I would get that h is less than 213 minus 40, which would be 173 feet. So either James Bond needs to fly above 253 feet in the air or below 173 feet in the air to avoid hitting that bridge. Cool. And last but not least, a gas station sells a bunch of different types of candy. A bag of W&Ws costs $6, a pack of Rizzlers costs $4, a Crunch Bar costs $5, a bag of mini This That's costs $8, and a pack of Geeks, I'm dying, costs $2. You don't want anything too cheap or too expensive though, so you decide to only consider candies whose absolute deviation is $1 or less from the mean or average cost. Which candies would you not want to buy? Alrighty, if you want to pause, now's your time. If you don't want to pause, well, now's your time. So, looking through everything here, I'm told that I want to find which candies I don't want to buy. So, my variable here, let's say that I'll use maybe P for price. I know that I'm looking to represent the costs of certain candies. In this case, my unit is going to be in dollars. And if I have a certain price of candy, I know that in this case, it's going to vary from the average, right? I want it to vary from the average cost. Well, if I'm looking at the average cost, to find the average, I take each of my prices individually, add them up, and divide by the number of things that I've got. So for my average cost, I'm going to take all 5 of my numbers. So I have $6, $4, $5, $8, and $2. And then I need to divide that by the total of number of things that I added up. Well, here I've got 5 things in total. 6 plus 4 plus 5 plus 8 plus 2. You might notice 6 plus 4 is 10. 8 plus 2 is 10. So I have 10 plus 5 plus 10. That's 25. And 25 divided by 5. My average cost is going to be $5. So, reading here, for my absolute value inequality, I know I want to be $1 or less. That's my inequality symbol, right? So here, if I need to be $1 or less, I could be less than or equal to that $1 I'm told is my absolute deviation. So here's my 1. $5 is going to be my given number or my average, which is my indicator. And then I just need to subtract that from my price here of P. Cool. So P minus 5, absolute value, is going to be less than or equal to 1. Again, looking at my inequality symbol, this here, I'm less than or equal to. I need to be sandwiched between the positive and negative cases. So that P minus 5 is going to be stuck between the positive 1 on the right and the negative 1 on the left. To get P by itself, all I need to do is add 5 to all 3 parts of my inequality. Doing that tells me that the value of P, my desired price, can be between $4 and $6. So I want to pay for a candy that is between $4 and $6, including the 4 and the 6. So the problem is asking me, what would I not want to buy? Well, the things that I wouldn't want to buy would not be within this range. So I don't want anything that's less than $4 or more than $6. What are the candies that fit into that category? Well, I've got the This That's, which are $8. I've got the Geeks, which are $2. So from this, what I would not want to buy are going to be the This That's or the Geeks. Magnificent! Congratulations, my dears. With this, you've now made it through all of Unit 3. Thank you very much for bearing with me. I know absolute value can feel a little bit weird, a little bit wonky, but it's an opportunity for us to not only stretch our muscles, but synthesize everything that we've done up until this point. I will see you in Unit 4, where we will begin our exploration of finding and graphing equations of lines. But until then, take care, be good. I'll see you when I see you. Goodbye.